Okay, we'll study about numerical differentiation and integration today. So that is in chapter number 4. So in chapter number 4, we have numerical differentiation and integration. So there are two topics. We'll be studying numerical differentiation first. Numerical differentiation in numerical differentiation there are two topics: differentiating a continuous function and differentiating a tabulated function. So we will be studying differentiating continuous function. Differentiating continuous function. So we have three formula for this: forward difference quotient. So in forward difference quotients, we have f dash x will be equals to fx plus h minus fx divided by h, where h is the increment in x. All right, so another one, backward difference formula or backward difference quotient. So replace h with minus h in the forward difference quotient. So you'll be getting backward difference quotient. So in backward difference quotient, f dash x will be equals to, replace h with minus h. So minus h replace गरे भने के हुन्छ यो fx minus h whole upon h. We'll put here minus h, so we'll multiply, we'll get this relation where h is the same thing. Okay, now we have central difference quotient. So in central difference quotient, f dash x will be equals to fx plus h minus fx minus h whole upon 2 into h. So these are the three formula for finding the first derivative of a continuous function where the function fx is given in the question. So let us do an example there. Let us write down the problem. Estimate approximate derivative of fx equals to x square at x equals to 1 for h equals to 0.2, 0.1, 0.05 and 0.01 using first order forward difference formula. The question says find the first order derivative using the forward difference formula. We know, let us write down the forward difference formula. F dash x equals to fx plus h minus fx whole upon h. What is fx given in the equation? So this is given in the equation as x square. So you need to find the first order derivative at x equals to 1 as said in the equation. It will be equals to f1 plus h minus f of 1 whole upon h. So for different values of h, calculate the f1h. Okay, you can do it. So let us do by using a table. for different value of h. So h is given as 0.2, 0.1, 0.05, 0.01. All right, we'll calculate first derivative at 1 using these h values. We'll also calculate error here to show how does the error vary according to h. h को आधारमा चाहिँ error कसरी vary भइरहेछ. So we'll be doing that. So put here h equals to 0.2. So f of 1.2 minus f of 1 divided by 0.2. Okay, we calculate it. It comes out to be 2.2. It comes out 2.1. It comes out 2.05. It comes out 2.01. For the exact value, so f dash x will be 2x and f dash 1 will be what? 2. So this will be the exact value of first derivative x square at x equals to 1, 2. So take the difference. And exact value सँग difference लिँदाखेरि के भयो यसको difference error कति हो 0.2 यो केसमा 0.1 यो केसमा 0.05 यो केसमा 0.01. So what you see here is that the error gets reduced as you take the small value of h. So difference in x तपाईले जति सानो लिनुहुन्छ त्यति नै error कम आउँछ. So this is one of the example of first order derivative for a continuous function. The function that is given in the question. Okay, fx given in the question. So let's do it for a higher order derivative. The second order derivative so they के गर्ने त हैन second higher order derivative. So in case of higher order derivative for the continuous function, so f double dash x will be equals to fx plus h minus 2 into fx plus fx minus h whole upon h square. So एउटा मात्रै formula छ. Let us do an example here. Find approximate derivative of fx equals to cos x at x equals to 0.75 with h equals to 0.01. Compare with the true value. So you need to compare with the true value as well. So let us do a solution. So fx के दिएको छ question मा fx is given as cos x. All right. So find the approximate derivative, approximate second order derivative. So order is mentioned. So हामीले higher order सोध्यो भने चाहिँ second order सँग मात्र पढ्नु पर्छ हामीले है. So find the second order derivative there. Okay. So formula यहाँ छँदैछ. So let's put everything in the formula. So we have f double dash x equals to fx plus h minus 2fx plus fx minus h whole upon h square. So all values are given in the table. So f x plus h, x हामीले 0.75 दिएको छ, h 0.01 दिएको छ. कति हुन्छ यो 0.76 minus 2 into f 0.75 plus f x is 0.75 minus 0.01 will be given as 0.74. Alright, so h square 0.01 whole square and you will get the result that comes out to minus 0.7300. So you need to compare with the true value as well, means calculate the error. So we have given fx equals to cos x, second order derivative of fx equals to minus cos x, second order derivative at 0.75 will be equals to minus cos at 0.75. Okay, So that will be equals to minus 0.7317. So take the difference, error. You can take an absolute value. So minus 0.731 minus plus, so 0.7300. We'll take the absolute value, so just show the difference. So this will give you the absolute error, so 0.0017. Okay, so this is the answer. So we have completed differentiating the continuous function. So first part is completed. So let us do another part. Second part, that is differentiating tabulated functions. योभन्दा जस्ट हामीले अगाडि गरेको चाहिँ के थियो भनेर भन्दाखेरि fx equals to x square अथवा cos x. So fx was given in the question. यसमा चाहिँ के हुन्छ भनेर भन्दाखेरि fx चाहिँ given हुँदैन, तर x र fx को टेबल दिन्छ हो, टेबुलेटेड फंक्शन. सो टेबुलेटेड फंक्शन दिन्छ, त्यसको आधारमा डेरिभेटिभ निकाल्नु पर्ने छ. लेट अस ट्राई टु डु इट. सो यसमा पनि तीनवटा फर्मुला छ. फर्स्ट अर्डर डेरिभेटिभको 3 point फरवर्ड डिफरेंस formula or quotient. F dash x equals to minus 3fx plus 4fx plus h minus fx plus 2h whole upon 2h. 3 point forward difference formula. So replace h with minus h. In this formula you will get a backward difference formula. So 3 point backward difference formula. So f dash x will be equals to 3fx minus 4 into fx minus h plus fx minus 2h whole upon 2 into h. So multiply with minus sign in the numerator as well. So another one, 3 point central difference so 3 point central difference formula ma f dash x will be equals to fx plus h minus fx minus h whole upon 2 into h. So that is a central difference formula. So let us do an example here. The table below gives the values of distance traveled by a car at various time intervals during initial running. You have given a table of time t in second, and then you have given the distance stored as st in kilometer. At 5 you have given 10, at 6 you have given 14.5, at 7 you have given 19.5, at 8 you have given 25.5, and at 9 you have given 32. So these are the time in second and these are the distance covered in kilometer. Estimate the velocity at time t equals to 5, t equals to 7 and t equals to 9 seconds. So this is a tabulated function, so we will be using this formula. So यहाँ तपाईलाई टाइम र डिस्टेन्स दिएको छ, भेलोसिटी सोधेको छ हो. सो द क्वेशनमा चाहिँ डेरिभेटिभ गर्नु भनेर कहीँ पनि भनेको छैन. सो हामी कसरी छुट्याउन सक्छौँ यो डेरिभेटिभको प्रब्लम हो भनेर भन्दाखेरि we know distance is the velocity is the derivative of distance. We know this. Velocity निकाल्नु भनिरहेछ is the first order derivative of distance. So time र distance दिएको छ, acceleration सोध्यो, that will be a second order derivative. Okay, so in this way you can say कि यो चाहिँ डेरिभेटिभ को प्रब्लम हो भनेर है. भनेको जस्तो हामीले योभन्दा अगाडि पढेको जुन इन्टरपोलेसन भन्ने टपिक हामीले पढ्यौँ हैन, त्यसमा चाहिँ के दिएको हुन्छ भनेर भन्दाखेरि x र fx भन्ने टेबल दिएको हुन्छ अनि तपाईले fx कै भ्यालु निकाल्नु पर्ने हुन्छ एट सम पोइन्ट्स. यसमा चाहिँ के हुन्छ, टेबलमा जे भेरिएबलहरु दिएको हुन्छ जस्तो टाइम र डिस्टेन्स दिएको हुन्छ भने तपाईले भेलोसिटी अर्कै भेरिएबल निकाल्नु पर्ने हुन्छ. सो दैट त्यसबाट पनि हामी भन्न सक्छौं कि यो चाहिँ च्याप्टर नम्बर 4 सँग रिलेटेड प्रब्लम अथवा डेरिभेटिभ अथवा चाहिँ इंटीग्रेशन सँग रिलेटेड प्रब्लम हो. अलराइट, सो टाइम र डिस्टेन्स दियो, डिस्टेन्स चाहिँ सोध्यो भने इन्टरपोलेसन हुन्छ, तर टाइम र डिस्टेन्स दियो, भेलोसिटी सोधिरहेछ, एक्सिलरेसन सोधिरहेछ भने त के हुन्छ, तपाईको डेरिभेटिभ हुन्छ. ओके, so in this way you can verify whether the given problem is related to interpolation or it's related to a numerical derivatives. Okay, let's do the problem. At t equals to 5 we use 3-point forward difference formula. सो फर्स्ट तिरको पोइन्टहरु छ भने फरवर्ड डिफरेन्स युज गर्ने, लास्ट तिरको पोइन्ट छ भने ब्याकवर्ड डिफरेन्स फर्मुला युज गर्ने. जस्तो t इक्वल्स टु 5 मा हामी फरवर्ड युज गर्छौं, t इक्वल्स टु 9 मा हामी ब्याकवर्ड युज गर्छौं र t इक्वल्स टु 7 मा हामी के गर्छौं, सेन्ट्रल डिफरेन्स युज गर्छौं. सो t इक्वल्स टु 5 मा चाहिँ हामीले भेलोसिटी एट 5 भनेको फर्स्ट अर्डर डेरिभेटिभ अफ 5 दैट विल बी इक्वल्स टु माइनस फर्मुला हामीसँग छदै छ. त्यो फर्मुलालाई अलिकति गिवन नोटेसनमा चेन्ज गरौँ, st प्लस h माइनस st प्लस 2h, x को ठाउँमा t छ अनि f को ठाउँमा चाहिँ के छ, s छ, डिवाइडेड बाइ 2 इन्टु h विल बी इक्वल्स टु माइनस 3. सो t को कतिको लागि गरिरहेछ हामीले 5, सो s अफ 5 प्लस 4 इन्टु 5 प्लस h भनेको डिफरेन्स इन टाइम कति छ, 1 छ नि त हैन, डिफरेन्स इन x हुन्थ्यो, यसमा डिफरेन्स इन टाइम, सो h equals to 1 छ. So s of 6 minus s of 5 plus 2 into 1, so s of 7 whole upon, so 2 into 1 we have, since h equals to 1. So minus 3 into s of 5, calculate from table, that is 10 minus 4, sorry, plus 4 into s of 6 is 14.5 minus, so s of 7 कति छ, 19.5 whole upon 2 into 1. So you'll get the result that comes out to be 4.25 kilometer per second. Write down the unit as well. So यस्तो केसमा चाहिँ फंक्सन दिएको छैन, टेबल दिएको छ, झन् सजिलो भयो टेबलबाट फंक्सन्सहरु यसरी राख्ने अनि गर्ने. सो यहाँनेरि मैले किन ब्याकवर्ड डिफरेन्स युज गरिन भनेर भन्दाखेरि जस्तो यहाँ हेर्नु भयो भने हैन, ब्याकवर्ड डिफरेन्स फर्मुलामा हाम्रो के छ, s माइनस h छ. सो h हाम्रो 1 छ, यहाँ त अझ s माइनस 2h हुन्छ हैन. सो यो 1 छ, यो हाम्रो 5 मा गरिरहेछ एट t इक्वल्स टु 5. सो 5 माइनस 1 भनेको 4, f अफ 4 टेबलमा छ, छैन हैन. सो यो गर्नुभयो भने के हुन्छ, f अफ 3 टेबलमा छ, छैन. सो हामीले चाहिँ ब्याकवर्ड डिफरेन्स युज गर्न सक्दैनौं त्यहाँनेरि है सेन्ट्रल डिफरेन्स पनि युज गर्न सक्दैन माइनस एच छ नि त एच 1 छ सो 5 मा गर्दाखेरि कति हुन्छ 5 - 1 4 हुने भयो 4 एफ अफ 4 टेबलमा छैन गिभन सो के बुझ्नुस् भनेर भन्दाखेरि यदि फर्स्टको पोइन्टमा निकाल्न भनेको छ भने फरवर्ड डिफरेन्स युज गर्ने लास्टको पोइन्टमा निकाल्न भनेको छ भने ब्याकवर्ड डिफरेन्स युज गर्ने अनि बीचतिरको पोइन्टमा छ भने चाहिँ सेन्ट्रल डिफरेन्स युज गर्ने ओके अब हामीले 7 मा सोधिरहेछ सेन्ट्रल डिफरेन्स युज गर्छौं 9 मा सोधिरहेछ ब्याकवर्ड डिफरेन्स युज गर्छौं so let us do here at t equals to so at t equals to 7 we use 3-point central difference formula. So we will be using so velocity at 7 will be equals to first order derivative of distance at 7 s dash 7 so that will be equals to s of 8 minus s of 6 divided by 2 into h that is 1 so 25.5 minus 14.5 divided by 2 that will be equals to 5.5 kilometer per second. So at t equals to 9 we use 3-point what backward difference formula. All right, so backward difference formula. So velocity at 9 is equals to first order derivative of s at 9 so that will be equals to 3 into s of 9 minus 4 into s of 8 plus s of 7 whole upon so 2 into h that is 1 you will get 3 into 32 minus 4 into 25.5 plus 19.5 whole upon 2 and that will be equals to 6.75 kilometer per second. All right, so we have calculated the velocity at t equals to 5 t equals to 7 and t equals to 9. So let us see higher order derivative for the tabulated functions. Higher order derivative for tabulated function higher order derivative we have three formula forward difference formula f double dash x will calculate up to second order derivative only so that will be equals to 2fx minus 5 into fx plus h plus 4 into fx plus 2h minus fx plus 3h whole upon h square. So backward difference formula replace h with minus h you will get the backward difference formula f of plus x minus h square is again h square so sign will remain the same so 2fx minus 5 into fx minus h plus 4 into fx minus 2h minus fx minus 3h whole upon h squared. Also write down the central difference formula for second order derivative f double dash x will be equals to fx plus h minus 2 into fx plus fx minus h whole upon h square. So these are the formula for forward difference formula, this is the backward difference formula, and this is the central difference formula for the tabulated functions. Okay, so let us do a problem. Related to second order derivative or higher derivative. So I'll do the same problem. use the table of data given in previous problem to estimate acceleration at t equals to 7 seconds. All right. So अघिको टेबल हामी युज गर्छौँ. अघिको टेबल के थियो हाम्रो? के टेबल थियो? अघि हामीले दिएको टेबल चाहिँ टाइम र डिस्टेन्स थियो, टी एन्ड एस थियो. त्यसबाट एक्सिलरेसन निकाल्नु पर्यो. के बुझिन्छ? एक्सिलरेसन इज सेकेन्ड डेरिभेटिभ अफ डिस्टेन्स. सो विल बी युजिङ द सेम टेबल. सो एट t इक्वल्स टु 7. सो 7 भन्ने पोइन्ट हाम्रो कहाँनिर थियो अहिलेको प्रब्लममा? सो 7 भन्ने पोइन्ट हेर्नु त बिचमा थियो. सो यहाँनिर हामी के युज गर्छौँ? सेन्ट्रल डिफरेन्स, सेकेन्ड अर्डरको सेन्ट्रल डिफरेन्स फर्मुला युज गर्छौँ हैन. सो विल बी युजिङ सेकेन्ड अर्डर सेन्ट्रल डिफरेन्स फर्मुला. सो विल बी युजिङ द दिस फर्मुला. अलराइट, एट t इक्वल्स टु 7. सो नोटेसन चाहिँ म चेन्ज गरेर लेख्छु. सो एक्सिलरेसनको सोधिरहेको छ एट 7. फर्मुला लेख्नु न त. एक्सिलरेसन एट t will be equals to second order derivative at t st. So st plus h हुन्छ minus 2 into st हुन्छ plus st minus h हुन्छ whole upon h square. Alright. So हामीले 7 मा निकालिरहेको छौँ एक्सिलरेसन. सेकेन्ड अर्डर डेरिभेटिभ एट 7 will be equals to st is 7, h is 1, so that is s of 8 minus 2 into s of 7 plus s of 6 whole upon 1 को square. So that will be equals to, so 25.5 we write from the table these values. S of 7 we write from the table 19.5 plus 14.5 divided by 1. Alright, that comes out to be 1 kilometer per second square. Write down the unit as well. Acceleration unit here is kilometer per second square. Okay, so now you can repeat the same problem. Repeat to find acceleration at t equals to 5. So use what? Forward difference. And t equals to 7 climbing t equals to 9 seconds. Use the backward difference, second order. So you can do this by using the formula. So by using the second order derivative formula for the tabulated function. So use this formula at t equals to 5 and use this formula at t equals to 9. Alright, so this is what we study in derivative. So in the next lecture, we'll be studying about the numerical integrations. Thank you.